Welcome, folks. Today we are discussing a research paper on the synthesis of new hydrazones containing a 1,3 dicato moiety. Let's dive in.
I'm eager to hear about this. What's the main goal of this research?
The primary aim is to synthesize novel hydrazones with a 1,3 diketo group. These hydrazones are important because they can be used as building blocks for other biologically active compounds, such as V-lactams and thiazolidinones. These are known for their potential antimicrobial properties.
So, they're not directly testing the hydrazones for antimicrobial activity, but rather seeing if they can be used to create molecules that could have that activity.
Exactly. Think of it as creating a versatile platform. They've synthesized these hydrazones, confirmed their structure using techniques like IR and 1H NMR spectroscopy. And now the next step is to use them to make V-lactams and thiazolidinones. The synthesis itself involved a condensation reaction between substituted malonanilic acid hydrazides and either 3-methoxy-4-hydroxybenzaldehyde or 3-methoxy-4-acetyloxybenzaldehyde. The yields were quite good, ranging from 62% to 83%.
Interesting. What kind of substitutions were made on the malonanilic acid hydrazides?
A variety of substitutions were explored. They used different substituted anilines to create the hydrazides, including those with O-fluoro, P-fluoro, sulfadiazine, and sulfaguanidine groups. This allowed them to explore how these changes affected the yield and properties of the final hydrazone products.
And how did those substitutions affect the outcome? Did they find any significant trends?
Yes, they did observe some trends. For instance, they found a positive correlation between electron-donating groups on the benzaldehyde and the yield of the hydrazones. Also, extending the reaction time from 4 to 6 hours significantly increased the yield. The substitution pattern on the aniline ring also influenced the solubility of the hydrazones in dimethylformamide, which is a common solvent used in organic chemistry.
So, the reaction conditions and the substituents played a crucial role in the success of the synthesis. What about the characterization methods? How did they confirm the structure of these new hydrazones?
They used a range of techniques. IR spectroscopy confirmed the presence of the characteristic 1,3 diketo moiety and the azomethine group. 1H NMR spectroscopy provided detailed information about the proton environments in the molecules, further confirming the structure. Thin layer chromatography, TLC, was used to monitor the reaction progress and assess the purity of the synthesized compounds.
It sounds like a pretty thorough characterization. What are the next steps for this research?
The authors clearly state that the next step is to synthesize the V-lactam and thiazolidinone derivatives from these hydrazones, and then evaluate their biological activities. They're particularly interested in exploring their potential as antimicrobial, antifungal, anticonvulsant, anti-tumor, and anti-tubercular agents. They also suggest that modifying the substituents on the hydrazones could further enhance their biological activity.
That's a promising area of future research. It's interesting how this work focuses on creating building blocks rather than directly testing a final product. It's a smart approach to drug discovery.
Absolutely. It's a foundational study, providing a library of compounds for further investigation. The authors have laid a solid groundwork for future research into the potential therapeutic applications of these 1,3 diketo hydrazones and their derivatives. Well, that's a wrap for today's discussion, folks. Thanks for listening.